There you go. Just a minute. There you go. Just need to keep it there.
Yeah, I always loved how that eye looked jumpy and all.
Yeah, well, you know, bits are falling apart. Well, welcome to the meetup, and thank you for joining us all. So, as we said, we've revamped our Software Circus, and we are really happy that you're joining us. So, an overview of what's going to happen tonight. We'll start off with a few intros, housekeeping, and some announcements. After that, we'll get into the scary stuff. We'll have Tom Kennis telling us about the horrors of self-stability and when the Kubernetes Scheduler meets the AWS Auto-Scaler. After that, we'll have some Q&As led by Tomasz. And after the Q&As, we'll go off with a second story by our own Dawid, talking about how hybrid cloud infrastructure and how not to do it. It will be all wrapped up by our own Sebi. So as I said, we'll go through some intro first, a code of conduct. Every meetup we do here at Container Solutions and Software Circus has our own code of conduct. Basically, we want to ensure that everybody feels included. We do swear every now and again here at Container Solutions, but we are not arseholes. So please be kind to each other. You can scan our code of conduct, and you can also use it for your own meetups and conferences. So please do use it. My kind assistant, Therese, will also be posting links as I talk. So who are we? Our new team enjoying Software Circus and applying our theme of Halloween today. So it's me, Tim, your zombie for today. Sebi, who would like to introduce yourself?
Yeah, I just want to say, I kept repeating, it was not a bug, it was a feature, but they insisted. So yeah, that's all I can say.
Thank you, Sebi. I'm loving the blood. And finally, Tomasz, who's rising from the dead. Tomasz, could you introduce yourself?
Yeah, I would always ask you to say my name, to repeat it 3 times, like it's a riddle, a beetle and the other thing. Yeah, and I think that's it for today.
Thank you, Tomasz. Well, we want to make sure you do know that we are recording this session, so all sessions will be recorded and then will be posted on YouTube. The link to our YouTube channel is being posted in the chat. Do subscribe and join us. Also join us in our Slack channel. If you have any burning questions that you want to ask to us, to any of the engineers at Container Solutions, or to the speakers of today's meetup, please join the Slack channel and ask any questions. Also, we're always looking for people who want to participate and give talks during these meetups. So even if you're a newbie, feel free to join and request to give your talk. Oh, we've got noises coming out from everywhere. So some Container Solution news. We have a newsletter. Please subscribe. We do not spam. You do choose what you want to receive. If you choose to not receive anything, we will not send you anything. But there is some really good information within our newsletter. So do subscribe to our ODF is cloud native. And also, next week, we have our conference. There are some amazing talks by Sam Newton. Who else? Help me here.
Jessica Rose is
Jessica
there.
Rose.
We
We've
have
got
shared
a long list of
Julie.
people. I myself will
So
be
many
joining
people.
with the conference. Do subscribe to the conference. It is a free virtual conference and you can join. And also on that note, we do have 2 watch parties, 2 in-person watch parties in Amsterdam and in Berlin. So if you are close by, do register for those. You will meet up with some amazing engineers. We will watch the keynote speeches and we will have some amazing chocolate cake. I'm not sure whether Brain will be involved in it, but it is still amazing chocolate cake. So off to our first speaker, Tom Kennis. Tom, are you alive?
Yes, definitely. I'm here, well alive, still living right.
Cool, awesome. I have stopped sharing. You should have the power to start with
Yes.
your scary story.
Can you see my screen now?
We can see your screen. I can.
Awesome. Awesome. Okay, then let's go.
Cool.
Thank you very
Before
much.
you start, I just want to make sure people do ask questions in the chat throughout the talk, and we will have time to do some Q&A at the end. Off you go, Tom. Thank you.
Okay. First of all, thank you very much for having me. Thank you very much for being here. I have to warn you though, this is a true story. This can happen to everybody if you don't take some things into account. Luckily, you can also avoid it, but this can happen to everybody. So first of all, I'm Tom, with a master in mathematics and econometrics. I've been working in the data and development domain for about 5 years. Currently as a cloud/DevOps consultant at Skyworks. And since October last year, I've been working at Volksbank as a DevOps engineer. So that's about me. Like I said, this is a true story. And I want to share with you some of the horrors we experienced when working with, maybe I should close this thing though, when working with Kubernetes, Jenkins, and AWS. I will first introduce some of the important topics here, explain our setup, and then explain how this all horribly went wrong. So, so first of all, the suspects. So we're using AWS EKS, the managed version of Kubernetes on AWS, where your nodes are basically EC2 instances. So that means that all the components of Kubernetes are managed by AWS, and it's really easy to scale up and down your cluster. That's all being done for you, so that's really convenient. There are 2 flavors when you're talking about the nodes that are important here. First of all, there's the managed nodes version, where you basically deploy a node group and AWS takes care of the rest. And you tell them this node group should be at max this size, minimum this size, and should be a bit in between. Pretty straightforward in the sense. You can also choose for a self-managed version, and then you really have to define your own nodes and deploy them to your node group. It's much more of a hassle. We of course went for the managed nodes because we like to keep things simple to some extent. Scaling these clusters with extra nodes is in a sense quite straightforward. As I said, you have a size, and within that bandwidth you can freely scale. The scaling works through EC2 auto-scaling groups, and basically when there are new pods to be scheduled that are not able to find a node to be scheduled upon, they become in a pending state. A message is sent to the cluster autoscaler. Yo, what's up? I need more nodes. Can you give me some nodes? If possible, these nodes are granted. Finally, the pods then are scheduled. Vice versa, the same thing happens when there are too many nodes and some nodes are below the threshold of their load. Then these nodes can be taken away and the workload can be rescheduled. It's important there to note that the workload should be able to reschedule, otherwise the node shouldn't be shut down. So yeah, that's all I wanted to say about node groups, I guess. Let me then explain to you how these things would work together when you would scale up a web application. For example, today is such a day that a website like Creepypasta, where you can find all kinds of creepy stories, might get a bit more traffic. I think that me myself, I might look up some stories tonight to get a proper scare. So today they might experience much more traffic than they normally would have. And if their infrastructure looks kind of like a standard Kubernetes infrastructure, they probably would have their applications running on some pods. In this case, I've drawn 2 pods behind a load balancer, so that the traffic can be dispersed over the pods behind it. And this is all on one node because we keep things small in this case, with a database that's not in the same cluster. When traffic increases, that you get an extra pod to handle the traffic. When traffic continues to increase, you might get an extra pod to put that extra node upon. You might get an extra node to put your pod upon, and then you're still able to handle the traffic. So this is basically what happens under the hood when we talk about auto-scaling groups, node groups, scaling nodes, but also about kube scheduling. So this is important to understand because we are going to place our application, Jenkins in this case, upon Kubernetes. We need to make a couple of adjustments, decisions to make sure that this is placed properly. So let's first things first. So let's start off introducing how our application looks like. So we're making use of a traditional Jenkins style setup, where you have one controller that's responsible for handling the incoming workloads and then distributing these workloads to the workers that actually do execute the build or the test or whatever. They do the actual work in the end. That's why they're called workers, of course. In our case, we've got 3 important different types of builds. We're working mostly in the Java development area. So we've got Maven, NPM, and the rest we just group together in simple builds, including XL deploy, XLD. So that's also an important actor. And I'll just refer to it as XLD later in these slides in this presentation. So this is basically what we're trying to set up, and every worker should be in a pod. We can have multiple pods per type of build. So that's what we should put on there. Then we go back to the drawing board and we started figuring out, okay, what are our needs? What do we need to comply with? How do we think it should be architected? What are best practices, etc. And we've quickly figured out that, well, these workers are going to have to accommodate a lot of potential load. NPM is quite resource intensive. Maven can be, but it's more okay. But in general, the workload can be quite dynamic during the day. Even though the workers, we want them to be static. So in the end, we opted for having high resource requests and making sure that these workers can grow when necessary and can actually work through the load that's coming to them. Next to that, when working with Kubernetes, you want to actually avoid huge nodes. You don't want to place all your pods in one basket, because if that node goes down, then you lose potentially all your work nodes. So you want to disperse them. Next to that, when you're working with the managed version of Kubernetes, then you don't really care about having too many pods or having a lot of load on your components that make up your Kubernetes cluster. So you don't really, you rather have 2 small nodes than 2 big nodes in a sense. So that's a bit of a trade-off there. Then of course, your workload should be handled with care. These are builds that can be run again, but in all, there are also some things that are more sensitive, and you want to make sure that they are scheduled properly, that the data is stored to the right location, preferably on the cloud, of course. So you have all these extra conditions and make your workload make that it should be handled with some care. And of course, finance department also has a say about your expenditures. So there is quite a firm grip on your cloud bill in the end. You have to comply in this case. So that's also a big factor in this design in the end. So summarize, Jenkins workers, when you use long-lived workers, then you want to provision them with enough resources such that they're able to accommodate whatever stuff developers throw at them. When you're working with managed nodes, use small nodes, preferably a lot of them. And when you run important workloads, spread out over multiple availability zones, use EBS volumes or EFS. Use something that saves your data, and don't overspend on cloud costs. So that's what we in the end thought we had quite a proper design for. We put everything in Kubernetes, and we were quite happy with it. And in the end, I think we can summarize the setup best with saying we scaled up our pod sizes, we scaled down our node sizes, we replicated these nodes and these accommodating stateful sets across availability zones, and we made sure that using node selectors, pods were assigned to each availability zone. And finally, we made use of AWS to store our data. Now, what could possibly go wrong? Also, we spent less money, so everybody wins, except that in the end we have every pod the same size as a node, and that's something that I'm going to come back upon, but that's not something that is generally recommended by practitioners, but by finance personnel it's a different scenario. So that's what we end up with. That's pretty interesting. So if you go to a more schematic view, then you would see that our npm, maven, and xld workers, they're spread out over availability zones, AZs, in the fashion as you see on the right. So we've got 2 npms per zone, 1 maven and 1 xld. In this case, every worker, npm, maven, xld, is 1 pod and is 1 node. So the square is, well, all these things at the same time. And these are then deployed using stateful sets, where we actually make use of a node selector that strongly binds a stateful set to a node in a specific zone. And you see that the failure domain. And you also see it in the name. So in this case, we've got Maven zone A. In this case, that reflects zone AZ is 1. So that's what we end up with. And that means that you basically have your AWS cluster Auto-Scaler that takes care of vertical management of one quite large node group that's dispersed across all AZ. And so every node is at this moment in time basically the same. At the same time, horizontally, the Kube scheduler is managing stateful sets, 9 of them for each type and each availability zone, and they are strictly bind to an AZ. So this is what we what we had to maintain, what we had to protect, and then of course things changed, as things always do. Pure terror started to reign in, and we were asked to make a couple of changes, which were quite right changes, because we did saw that the consumption of our resources started to change. Developers started to use more npm, so we had to put more npm workers in there, less maven, less xld. So we want to scale those down. So if you see from the left to the right here, we basically wanted to put 1 npm worker in every AZ and put away with the maven and xld in AZ3. So that was our goal. And something remarkable, yet quite horrific, happened. Because as you would expect, first things happened quite okay. The two nodes in AZ3 that hold Maven and XLD, we can easily just scale down the stateful set, and there's not really a problem. The nodes become empty, but they're still there. Same for scaling up in the NPM across all the AZ. We just scale up the stateful sets per AZ, so that doesn't really give us much of an issue. But then the question, of course, becomes more difficult, because then what happens is that the cluster Auto-Scaler is asked to scale down the nodes, and you hope that, well, when you expect that it would scale down the 3 nodes. But apparently what happened, it started, we first saw the Maven pod in the AZ1 disappear. It was evicted. Because the cluster Auto-Scaler actually started to remove the underlying node. So, so here instead of 4, you see that the node that used to host Maven, that's actually gone, because it has been removed, because apparently there were too many pods, too many nodes. This means that the kube scheduler then is tasked again to reschedule the pod, and of course this pod is meant to be rescheduled in AZ1, but there's not enough nodes, so it tells the cluster Auto-Scaler, yo, what's up? I need more nodes. Can you give me some nodes? But at the same time, the cluster Auto-Scaler also gets a message that there are nodes that don't have any load, so there can be some rebalancing, and it starts looking which node can I remove. And it's not unlikely in this case that the same thing happens again, that you see instead of 5, that again it removes, it starts to evict a workload and remove that node because it just does so. So in this case, you see the same thing happens again. Again, the wrong workload is removed, the wrong pod is removed, and we start to get into more and more of a trouble. And actually this went on and on for a couple of hours. Luckily this was during the weekend, so there was not much of an impact, but it was a bit difficult to figure out what was going on there, except then that we saw that it started to evict, rebalance, remove nodes, add nodes. So yeah, that was quite a horror. So the question is then, why does this happen? And the answer is actually pretty straightforward, because the cluster Auto-Scaler just looks at nodes and thinks they're all somewhat the same. It's not zone aware when it scales down. It just sees, I've got 15 nodes. Those nodes don't have enough load on them, so they are under some threshold, so I can remove them. And it just picks then one of them, even though that node was really important in that zone. Next to that, you also see that it doesn't really communicate with the kube scheduler when it talks about, well, is this node necessary? Can this pod go anywhere else? It does a little bit, but it doesn't communicate enough. It kind of also comes down to that auto-scaling unpredictable workloads is quite hard. Doing it across multiple AZs appear to be incredibly difficult. So next question is, well, how can we solve this issue? How can we actually mitigate sort of the probability of this happening, rethink our architecture, find solutions, analyze situation? And in order to do so, I found a couple of solutions, and they all have different impact on the system. And I think it's good to score them based on a couple of different axes. So first and foremost, can I effectively scale up and down my cluster, my number of nodes, using the cluster Auto-Scaler? Thirdly, is it possible to load balance across multiple AZs? which is something that you want to be able to do if you need your workload to be, well, multi-AZ. That's something that we were just looking into, but that's something that we hadn't been doing before. That's to really match our workloads to a type of node. So that means that you would use a more memory, a more powerful memory type when you're working with NPM, or use something that has more threads or CPU for the generic one, so that they can handle more concurrent builds. Those kind of things that might also be interesting to better the performance in the end. And finally, the fifth axis is conflict avoidance, and that's really can I avoid the probability of an occasion where the cluster Auto-Scaler and the kube scheduler are arguing or not really agreeing upon something. Can I put down the probability? Can I avoid this from happening at all? Maybe can I make sure that this does not occur that much? And there are a couple of solutions. So first of all, there's pod disruption budgets. I think this is the one that comes to mind by most people most quickly. And pod disruption budgets basically tell you I want to keep at least X pods available, or at max iPods unavailable. And in this case, you would be able to tell Kubernetes, this pod on this node should not be evicted because a node is meant to shut down. And that way, the cluster Auto-Scaler can take this into account. So this would be a solution, but it would only solve scaling down. If you scale up, it could still be that a new node is placed in the wrong availability zone. So you still would have this issue, and you still might run into some trouble there. But you maintain the potential of load balancing across the whole spectrum of AZ. So that's nice. That's nice. And if you don't do anything, you would expect that the system resolves itself faster. So that's more self-stability. Then again, you can also focus on node groups per availability zone. So and then you would really split it up. Now we have one big node group that spans the availability zones, and then you would have just 3 different ones, one for each AZ. This is actually the preferred solution that most players in the field also recommend you, because it syncs better the scope of the scaler and the scheduler as well. This is also mentioned by Weaveworks in their documentation around EKS-CTL. And also supported, I believe, by AWS if you look at the features that they are planning to put into production or that already are there. For example, you have the flag that says balance similar node groups that allows you to say, well, if you have 3 node groups, the same type, the same minimum nodes, maximum nodes for different AZs, then you can automatically have them be balanced, basically. So that's quite nice if you want that. Of course, in this case, you can't really match your workload, your node type to your workload, and you also don't really you really sacrifice the possibility of scaling across your availability zones. So it's a bit of a trade-off, but it's the one that is recommended. You could, of course, go the other way around and use node groups per workload type. In this case, this is really the other way around, because you retain the possibility of balancing across the AZs, and you can actually match your workload better to your nodes, but you don't really solve anything. You don't really solve the problems we just saw. So, nice, but maybe you could combine it, of course, with the previous one and have node groups per type and availability zone, but then you might have a lot of node groups that you would need to maintain, which it's a bit of, I don't know if that's the best solution. Depends, I would say. Then this is something that we heard a lot, better pod and node sizing, or said otherwise, don't make pods the same size as your nodes. fair point. But if you have larger pods and schedule larger nodes, if you have larger nodes and schedule multiple pods on the same node, then you still might have this issue because nodes can still be removed or added at the wrong availability zone, and you can still have this this lack of communication between the scaler and the scheduler. You would expect that it would occur less frequently because in this case the scaler and the scheduler are not managing the same logical unit anymore. So that's this some win. Then again, you can also focus on better replication sizing. So then you really make the number of replicas a multiple of your AZs. So in this case, when you have 3 AZs, you would have 3, 6, 9, etc. replicas, such that it can be balanced across your availability zones. It doesn't really solve the issue that you have because you can't size down the way that we wanted to size down, just really granular. You can size down, of course, but then you would size down per tree, and that's not something that you might want in this case. I mean, that might be too much. It really depends, but yeah, that's my reaction when I heard this. So looking at all the solutions and the scaling axis, it's a bit of a all over the place, and it's really this is really a problem that's not fixed yet. So this kind of means actually that when you get this far that you have this issue, maybe you should have rethought your design much earlier. That's more or less the takeaway that you actually come with. But then again, it's interesting to see what happens when these things go wrong and what can go wrong. So if you look at the table, you could, for example, do node groups per AZ, node group per workload type, as I just mentioned, and you're fine. You're ticking all boxes, and well, that's someone in there. Or for Jenkins, forget about static workers, use Kubernetes. Then you have dynamic workers, and you don't have this issue anymore. But that's really for Jenkins specific. That's something that we also have for our new platform. So, which works much better because workers only exist when a pipeline runs, and then they're just gone. So you don't worry about scaling as much as you would do before, and it makes things a lot easier because it's much more Kubernetes native in the sense. So as key takeaways, scaling is hard. If you don't need it, don't do it. If you only expect your website to have more traffic during Halloween, you don't really need auto scaling. You can just manually scale up, scale them afterwards, or maybe schedule that manual scaling if you want. Fine, but you don't need to auto scale for 1 day a year. That's too much. That's over engineering. If you can, try to make workloads zone independent, and then you don't have this problem also, because then your stateful sets don't need to be bound to a AZ. So that basically means don't use EBS, use EFS, which can be multi-AZ, maybe S3, but it really depends on your use case. And then don't bound pods too tight to certain nodes. So try to be careful when using pod affinity, node affinity, and node selector, which is the one we used in the end. And if you do tick any of these boxes above, think about balancing your workload, balancing your nodes equally across AZs, because this is something that the cluster Auto-Scaler does automatically. It tends to favor a setup that has this symmetry. So that was my presentation, my talk. Thank you very much for having me. Then are there any questions?
Thank you, Tom. Thank you very much for a great talk. Let's check. So if anyone has questions, please just speak up here, or you can also put them in chat and we will read them. I think there's one question from Tim, actually. Tim, do you want to ask it?
Sure. So really like the talk and how you went through the different decision points, the pros and cons of everything. But was there a point during this whole process where you went, you know what, just start over again, re-scratch, let's redesign everything properly? What would have been the outcome of that?
Yeah, so we really just went for it in a sense. Yeah, this was just moved from a different infrastructure to EKS without much thought. And in the end, we actually scaled back again to our previous infrastructure because, well, as I just mentioned, we also have a newer version which does have these dynamic workers, which does make things easier. So we kind of avoided the problem in the end, which which in my opinion is a major redesign. But if I would have to go back and redesign it, then yeah, then it was definitely I think about half an hour in when we just saw things flying around, being deleted, being popped up again. It was it's really amazing to see it so out of control. Yeah.
Okay, let's check. Yeah, no questions in the chat. If anyone wants to ask something, please do so. I also have one question from myself. So you talked, or you touched on using the Jenkins Kubernetes plugin. Like, what would be the main difference then? Like, would it mean we can avoid the whole problem at all, or?
Yeah, Jenkins is not really made for Kubernetes, I think. I mean, the old setup, the traditional style where you already have static workers, and they are basically huge servers that do your jobs. And the nice thing about the plugin is that that your workers only exist while the pipeline runs, and afterwards they are just taken away. So you don't really have this problem of scaling up and down static workers. You just make sure there's enough room on your nodes for your pipelines to run. If you need, you can, well, adjust. But it's much easier to scale in that scenario because you scale all the time, basically.
So it would be more similar to this like microservices world, like short living and short task.
Exactly. Durable, ephemeral, and all the one.
Okay, that's great. Do we have any questions from the audience? Or if not, yeah, I think you can still ask questions to Tom in chat here or reach out later on. Okay. And then let's move on to our next talk. So yeah, thank you, Tom, once again.
Thank you.
Yeah, it was a great talk. And then next, applause.
Thank you, Tom. That was amazing.
Thanks.
Yeah, and then next in the program we have Dawid with us. So Dawid, he works at Container Solutions together with us as a senior cloud native engineer. I have two interesting facts about Dawid. So Dawid, welcome to the meetup, first of all.
Hello.
I've heard that you actually started your first IT job at the age of 14, more or less. How did that happen that you started so early?
Yeah, so it's funny story, a bit embarrassing, but still funny. So I come from very, very, very small village. So everything was coming to me with a sort of delay. So I got my first computer, when I was like 14 actually. And because on that village of mine, I was actually living even 1 kilometer from the village. So I was basically living like in the middle of the woods. So there was literally nothing to do, right? So when I got my first computer at the age of 14, that was like complete change of my whole life, because it was something so new, so different, that I just got into it like immediately after like 1 month trying out Paint and using Windows Media Player. I just started trying to realize how it actually works, what's Windows, how to install it, and yeah, that's how it all started.
Wow, that's really great. Okay, so you gonna talk today about hybrid cloud and some scary stories around that, actually how not to do it. So I presume there would be some anti-patterns that we will learn about.
Yes, exactly. Maybe some of the stuff will be just like stating the obvious, but nevertheless, I think it will be helpful for some people, some companies moving to hybrid cloud or already in the hybrid cloud. So yeah, there will be some scary stuff, I think.
Okay, that's great. Can't wait to hear it. So without further ado, the stage is yours.
Okay, thank you very much. Let me share the screen then. Okay, I believe you all see it now.
Yeah, it works.
So yeah, just like I said, we'll be talking about hybrid cloud, how to not do hybrid cloud. Yeah, let's go to it. So I'll quickly explain you who I am, because that will help you understand why I'm giving this talk. So yeah, just like Tomasz mentioned, I'm Dawid Ziolkowski. I'm working at Senior Cloud Native Engineer at Container Solutions. And I'm far less advanced in dressing up for this talk today as my colleagues, because yeah, I had a crazy day. Slept 3 hours, been on a very last minute business trip to the client. But I prepared some visualization for you. How would I look like if I would have a bit more time to prepare? So here it is. So I'm working as a senior cloud native engineer at Container Solutions. It's actually so Container Solutions is a consultancy company. So what it means that I usually go to different clients and do different stuff, but most of that stuff is related to cloud native. Lot of the project related to migration to the cloud. And sometimes it's brand new, just moving to the cloud, let's build everything from scratch. But very often, I think the most type of project we have is hybrid cloud scenarios. So yeah, let's talk about actually what hybrid cloud is. For those who don't know, hybrid cloud is simply a solution where a client or a company has an on-premise infrastructure, so they have their own data center or their collocate or whatever. They have their own on-premise infrastructure, and they also have a cloud. And thing here is that these two are working together. That's when we have a hybrid cloud, because if you have a situation that you are on different clouds, so I don't know, you have some infrastructure on AWS, some infrastructure on Azure, that's not hybrid cloud, that's multi-cloud, right? And also if you have on-premise and you also have a cloud, but they are just two separate things, completely different teams managing two different applications, that's also not hybrid cloud, that's just on-prem and cloud. So purely hybrid cloud is when, yeah, you have on-premise infrastructure and you have a cloud. Typically what you would see is that, for example, you have your application running in the cloud, but the database that application is using is on-premise, right? So then you need to have that connection from the cloud to on-premise. So yeah, that's a very typical approach of hybrid cloud. And I mentioned that hybrid cloud is one of the most popular cloud deployment models, right, between private cloud and public cloud. And I think it's because it sort of makes sense, right? When you are on premise and you want to move to cloud, starting everything from scratch in cloud doesn't really make sense, right? Maybe in some specific scenarios, like you want to build completely new department or completely new application, then maybe it's easy for you to start from scratch in the cloud, but in most cases, you just want to do it gradually, right? Especially that we are talking about big companies, not like startups who has one application and it can move to cloud in one weekend. But if you have dozens of applications, hundreds of servers, then you simply can't move to cloud over a weekend or even in a month. That's why that hybrid cloud is sort of easy way or gradual way to move to cloud. Okay, so typically we're talking about hybrid cloud, but maybe let's take a step back and talk about cloud itself, right? So why companies move to cloud? There are 1,000 different reasons, and it very depends on the company. One company can move to cloud because of flexibility that cloud gives you, meaning that you can spin up servers whenever you want. You need to wait for the new servers to be delivered to data center, stuff like that. Another company can move to cloud mainly for scalability, like you can scale for, let's say, Black Friday easily. Again, you don't need to waste resources in data center waiting for that. Another company can move to cloud for, let's say, developer experience. So purely for the fact that applications team can manage their infrastructure easier because they don't need to call like central team. They don't need to call data center technicians to make changes. There are many, many different reasons. But the point is, in general, of course, that's not black and white, but in general, cloud is seen as better than on-prem, right? For all these reasons, scalability, flexibility, and stuff like that. So overall, cloud is seen as something new, something modern, something better, right? So if we imagine on-prem infrastructure as standard internal combustion engines, so like gasoline cars, normal cars that we have, and cloud, if we imagine cloud as electric cars, right? So this is that sort of view that most companies have, most people have, right? So when you think, okay, let's do hybrid cloud, right? We can't move to cloud at once, so let's do hybrid cloud. So what you expect is that you get all these advantages, right? Flexibility, scalability, again, you name it. And ideally, that how it would work. But in reality, very often it's not. So this talk will be exactly about that. Why very often that hybrid cloud doesn't look like you expected and looks something completely different. So let's go to it. Maybe I should have also mentioned at the beginning of this talk, just to manage some expectations. I'll be giving some technical examples, but this talk is more high level, just discussion sort of thingy. If I would be better at making jokes, that could be sort of stand-up comedy about hybrid cloud or cloud in general. So I'll give you some of the examples based on my experience, based on consultancy work we do. But don't get me wrong, it's not black and white. Some of the stuff I may be talking about may not apply to your company. Some of the stuff may be true in very specific cases. But nevertheless, these are the things that we see the most. Now, hybrid cloud projects, I always have sort of love-hate relationship with them, because when we get a client who just want to move to cloud and can start from scratch, these projects are usually relatively easy. I mean, it's very hard to make it bad, right? Anything you build in cloud, if you build it from scratch, then it's sort of by design will be nice, right? Of course, there may be some circumstances like it wasn't as fast as kind of expected, or it wasn't as flexible, but in general, there's not many stuff that can go really wrong. When you're just moving to cloud. But in hybrid cloud scenarios, there's a lot of this kind of stuff, and a lot of this stuff are there already when we are coming, which means we very often don't start from scratch, which is part of the problem that I'll be talking about in a second. So that's the hate part in this kind of project. The love part is that exactly this makes it sort of more interesting, right? It's more of a challenge to actually make it work. So, shall we go into actual details? Now, there are very few, I would say maybe 2 or 3 very very specific reasons why hybrid cloud is very often crap, let's say. But there are well, more than just a few reasons, right? So I'll just go one by one, and later on we'll discuss which are the most that we see. So first point on my list is that CISO department, so security department, very often is seen as it's sitting somewhere in the basement, in quotes, of course, and is only there to give us green light or red light once we do the move. And this is really bad for hybrid cloud scenarios for a couple of reasons. First of all, the fact that they are never, or well, never, they are very often not part of the team that is actually building the hybrid cloud environment, makes it tricky, because we of course they need to approve the environment at the end, right? So it needs to be compliant, needs to be secure and stuff like that. And they probably will give you some sort of checklist or some sort of guidance or anything that you can sort of based on building hybrid cloud scenarios. But the problem is that building hybrid cloud is also not something easy, let's say. It is quite complicated because you need to deal with cloud specific things and you need to deal with on-prem specific things. So the fact that the CISO team is usually not part of the process, but sort of only giving green light or red light, makes it complicated, because you always will have to like go back to step 1 or go back a few steps before, because CISO team realizes, oh, this can be done this way, right? So you may be spending, I don't know, 2 weeks, 2 months on designing, let's say, networking infrastructure according to the general idea of how networking is supposed to look like according to CISO, and you sort of, after these 2 months, you're like, okay, this should be fine, this should be secure, this should be compliant. And then you go back to that CISO and they're saying, oh no, actually we don't like this specific part of the process. And this is really something we see very, very often. I have no idea, to be honest, why is that? But generally, the security teams are very often somewhere hidden. And even if we, as a consultants, try to like bring it up and make them come to the meetings, sometimes they show up, but generally there is this wall between CISO and the rest of the company. They're very siloed. So this is definitely one of the very, very, very big problems in hybrid cloud scenarios. Another one sort of related to that, but not totally, is custom authentication solutions. Now, when you are on-prem, you have your application. Very often we see that companies build their own authentication solutions. And this is not specifically for the users, actually, because that can be pretty simple, like something like Active Directory or something like that, but more for applications. Very often we see some custom components which are sort of proxy components between some authentication mechanism towards the application. And while on-prem itself, if you look on on-prem itself, there's nothing wrong with that per se, right? You want authentication, you want it to be secure. So sometimes there is a need to build some custom connectors. The problem is that when you're moving to cloud, this makes it really, really, really complicated. It makes it complicated because networking in hybrid cloud is complicated. I'll be talking about in a second. And because of that, you'll have that custom proxy components or whatever authentication connectors on-prem. You'll have to make this sort of network calls from application on the cloud back to on-prem to get some token or some cookie, and then back to the cloud. And then that only gives you access to what you actually need to access. And this is problem not because of just having that connection back and forth, because that's not that big of a deal, but it's a problem because having sort of secure connection, or let's say having proper port opens, or having in general this secure data flowing in this kind of scenario is something. It's not something that you can do easily. It's something that always gives you a headache, and there will be fights with CISO how to actually do it, if we are allowed to do this or not. And another aspect of this specific problem is that when you are going to cloud, right? So when you are in hybrid cloud scenarios, very often you'll be also moving at the same time to containers, right? Because that's how we usually move to cloud these days. And if you have your application container on cloud, then cloud provider will give you a lot of easy ways to make authentication secure, like out of the box, right? For example, if we have an application on AKS, on Kubernetes from Azure, then you can have the pod identity assigned to the pods, which means that pods, the application in the pod can securely connect to Azure services, so like to storage or databases under the hood. And you don't need to do much, you just enable that. So authentication is really easy. But if you have that custom authentication connector somewhere on-prem, which needs to go like in the middle, that basically makes you, it takes away that easy authentication on the cloud, right? You can't use pod identity anymore because you have to make that call on-prem, and it's just sort of not compatible. So this is another problem. Two next items on my list. Yeah, this may be stating the obvious, but I'll tell you something about that. So you will probably see a lot of manual interventions or approvals required to do anything pretty much. Again, we these days we talk about automation and automatic provisioning of everything. So having manual anything seems like something from the past. But when you are on-prem, sure, you can still automate. Yeah, sort of. Even private cloud scenarios you can do. But if, for example, or the other around, some processes could, even if they could be automated, it doesn't really make sense on-prem, because if you, for example, need to you are building completely new applications, so you're building some new department or something like that, then you'll have to order, I don't know, a few more racks to your data center, right? And that's not something you do overnight. That's something that takes a couple of weeks anyway, because you'll have to wait a couple of weeks for servers to be delivered. So it's nothing really wrong that this process is manual, because then again, you anyway need to wait a couple of days or weeks for the delivery, right? So it's not that bad when you are on-prem. But then obviously when you are going to cloud and you want to leverage all the flexibility and easy scaling up and down, this is of course a problem, right? You will get stuck. And in the worst case scenario, you'll pretty much defeat the whole point of moving to cloud, right? Because you're moving to cloud to have flexibility to be able to spin up the machines up and down. But if you'll have somewhere some approval needed in the meantime, which is manual, it can take a couple of days, then again, what's the point of moving to cloud in the first place, right? So next point, which may seem very similar, processes built for on-prem way of working. This of course includes manual approvals as well, but here is something I want to tell you. So what means that process is built for on-prem way of working. Now, when you are building an application, right, and you are bringing some sort of well, connectors, or let's just say, let's make it simpler. You have an application, new application, you are developing new application on-prem, and that application, of course, will have to connect to some database, and maybe will have to connect to some other applications on-prem. And normally, what you do, you probably need to make some design documents. You'll have to ask for some permissions. You'll have to ask for some firewall requests to be open. But all of this, once you have it initially set up, then it's sort of clear for everybody, right? It's clear for CISO that, okay, there will be new application. It will be connecting here or there. It will be clear for procurement. So, okay, maybe we'll need some service, maybe or not. But along the way, when you are developing that application, there may be some changes, right? Of course, you can't know everything up front, so there may be some changes needed along the way. And once you have the changes in this sort of on-prem environment, then it's kind of pretty easy to amend the initial plan, right? Because you had the design documents, everyone was sort of aware that you are building that, and now you're just telling, hey, so sorry, I was about to connect to that database, but now it turns out we are connecting to the other database. We need another firewall rules, right? And this is sort of normal, right? No one will complain about it, and people will be aware about it. But when you are going to the cloud, you will, by design, if you don't, then again, what's the point? But you will probably by design want to give developer or applications teams more freedom, right? So you want that sort of flexibility of the cloud, also for the reason of creating POCs, doing some experimentations or hackathons or whatever. So by design, stuff in the cloud will be much more ad hoc, much more coming up out of blue, out of nowhere. And this is completely opposite of the way of working on-prem and how the processes for getting approvals and stuff work on-prem, right? So all of these people who needs to give you approval or permission or whatever may get sort of lost, and they'll be like, oh, where is this application coming from? Why are we talking about connecting to this database now? What is this component anyway? This sort of chaotic, creating confusion, not knowing where stuff coming from will be, this will be the point of view of people from on-prem side, right? While from the cloud perspective, that's sort of normal, right? That's the part of experimentation, having POCs and stuff like that. So process built from on-prem way, they need to change, simply, simple as that. They need to change. When you're moving to cloud, you need to be sort of aware that some things will have to change, process will have to be adjusted. But the real problem is that a lot of people, or like all people, all companies who are going to cloud, they sort of understand that, right? Because, well, it's obvious, right? When you're moving to cloud, you will have to adjust some processes. But even if people understand that and have that sort of in mind, they don't do it. They still don't do it. The processes are still the same. Everyone keeps saying, yeah, we understand, we need to change that, we need to change that. But it's always somewhere at the very end of the backlog, because of course the most important is to have the automation, write the Terraform code, and have that hybrid cloud done. And keep pushing all these processes changes at the end. It just makes it. It just makes it like the second picture, because you will be hitting roadblocks all along the process of building hybrid cloud. While if you would tackle these issues first, changing processes, the whole transformation or move to hybrid cloud would be more easy, basically. Easy, simple as that. So that was from the, let's say, on-prem people point of view. Now, if we talk about the cloud, so in hybrid cloud, what I don't really understand still myself, but what it's almost always the case is that the security team, so may refer to the CISO again, the security teams also sometimes applications teams, they treat the cloud environment by default as not secure. I don't really know where is this coming from. I mean, I understand, of course, that yeah, you are used to having everything in your data center, so you know exactly what security is there. So you have sort of this this idea of, yeah, everything is under your roof, so it's sort of secure. And because that cloud is somewhere, you don't know where, it must be not secure, right? Well, again, I don't really know where it's coming from, but this creates also specific issues. Cloud should give you a couple of advantages, couple of advantages, right? Again, flexibility, scalability, easy testing or easy experimenting. But if you flip it on a belly, making, oh, cloud is not secure by default, which means no firewall rules are allowed by default, and you need to ask for every single firewall rule to be open for every single simple test you want to make, then again, it sort of defeats the whole point, right? Sure, you can still create some Kubernetes clusters in the cloud and play it there. But if you can't really make this easy testing with what's actually you're caring about, right? So your application on-prem or data that is on-prem or whatever, then again, you are getting, or you are stripping yourself away from the benefits of the cloud. And I'm definitely not saying that you should trust the cloud by default. Definitely not the case. It's also very easy to have some data breach or expose some data which you shouldn't supposed to in the cloud, right? Because it's as easy as someone creating or using template Terraform code to deploy storage account and forgetting that it needs to be changed from public to private, right? So definitely security, there is security that needs to be put in place on cloud, but having that mindset that, as soon as it's in cloud and it's not secure, so we need to put first 5 different cages around it before you can do anything. Again, it's sort of strip you at the beginning from pretty much most of the benefits of the cloud. And that also brings me to the second point, flexibility, that developer experience, that giving this easy creating machines or cluster to applications teams. So one of the very very important arguments of going to the cloud. This is very often seen as getting out of control, right? People, especially on the management level, they keep saying, well, we can't just allow developers create their own infrastructure or manage their own infrastructure, because then we don't know what's there. We don't know what are they creating, how many machines or cluster we will have. We just lose all the control, right? Well, it's sort of true and it's not true. If you put it that way, then yes, but no one is asking you to just give developers, create developers account on cloud and let them do whatever they want. That's not what that cloud flexibility is about. It's very easy to make general guidelines and have that general governance, set up few policies on the cloud, or depending on the tool you are using, just restrict what you know that you can't have, and then use build some sort of component, right? So of course, I'm not saying just create developers accounts on cloud and then you're done. But if you build very easy component that well, component doesn't have to be component, it can be, for example, a pipeline. So if all the cloud provisioning is going through one tool, yeah, either Terraform modules that are created or GitLab pipeline or Jenkins pipeline, or whatever, once you have that one point of contact, then what's the problem with the control, right? You can easily see who created, and you just make few policies that, for example, you don't want VMs to be created with public IP, or you don't want Kubernetes clusters to be created with more than X pods. These sort of restrictions are easy to do and are giving you that idea of having control. Well, it's not actually idea, right? You are getting that control. You are getting that thing that you think you are losing by going to the cloud and giving developers flexibility, right? So definitely giving applications team flexibility doesn't necessarily mean that you are losing all the control and you won't know what you have in the cloud. Next, I called it too modern because that's what customers very often call it. So what I mean by that is that whenever we have the hybrid cloud environment, then we often see this sentence that that cloud is too modern. That's why we only use it as an extension of on-prem, right? So pretty much they only allow or they only use virtual machines on cloud and maybe Kubernetes cluster. Oh yeah, and storage because that's all you need, right? But the point is that if you are limiting yourself to the very basic resources, again, like VMs, storage, and IKS, then yes, you still get some sort of advantages from going to the cloud because yeah, you can spin up VMs how often you want, but having that restriction or maybe not even a restriction, but thinking only about this kind of services or thinking in general about the cloud as just an extension on-prem strips you again away from many advantages that you could get. For example, if your application is containerized, right, then you mandate that it's going to be deployed on the cloud in Kubernetes cluster, right? Well, that's not the only way of deploying container in the cloud, right? You can also deploy container as a container. Think about serverless stuff, think about Service Fabric if you're using Windows Container, think about app services. There are many different ways of doing the same thing in the cloud. And if you will be only thinking about the standard ways, let's say, right? So again, just thinking about extension of on-prem, then yeah, for first, you're losing many benefits. Second, you may be simply paying too much or more than you could with other approaches. And basically, when you will be building all the automation and all the governance across your hybrid cloud and these pipelines, let's say, for example, to deploy stuff, if you are building all of that, so basically, if you are building a whole hybrid cloud with only basic services in mind, even if you may thinking that, okay, that's only for the beginning and later we will check all these new fancy services from the cloud, you will end up in the situation that after, I don't know, 1 year, 2 years, 3 years of building infrastructure, building hybrid cloud environment, you will have that hybrid cloud environment, which will have to be redesigned again. So you'll have to spend another year or two adding all of these services, because it's not as simple as, oh, we just extend our pipeline to now allow functions. Because networking, again, we'll be talking about networking at the end. Networking is complicated in hybrid cloud. And if you don't have all of these different, let's say, services in mind from the beginning, then yes, you will end up in the situations that after you finish, after you are ready to celebrate, you will realize, oh, actually, we need to start pretty much from scratch to now have that hybrid cloud, the actual hybrid cloud, and not just extension as on-prem. Next, compliance. Relates to the first point I made about having treating cloud as not secure by default. But there's also another thing specifically when it comes to compliance. So yeah, mostly it relates to financial institutions. But the point is that yeah, having anything that relates, having any solutions that requires compliance approval, like specific compliances being approved by according to some specific rules, it's not easy. That's what people think. And actually, well, it's true. It's usually not easy. But the reason why it's not easy is not because of the cloud. So, right, so people say it's hard to create, or it's hard for a bank to move to the cloud because all the compliances, right? Well, cloud itself, it's not something that kills your compliance. What's difficult in this is that the way companies usually approach compliance is very old school, very slow, and very manual. What it means that if you have your on-prem environment, right, which you had for last, I don't know, 5, 10, 20 years, then you probably had to go through the compliance approvals once, or maybe twice, 3 times if you make some redesigns. But the point is that traditionally, if we were talking only about on-prem, compliance is something that people think as, okay, we spend X amount of weeks or months to go through the compliance and we are done. We never have to think about it again, or maybe if we change something, right? But this makes the whole compliance process by design manual and slow and not automated, right? So when then you want to go to hybrid cloud scenario, and you want to go to cloud and you want to do the compliance again, then it's again the same story. Or it's difficult in the cloud because it's difficult in the cloud, right? Well, that's where I'm getting at. It's not difficult because of the cloud. It's difficult because you had your compliance process done once 10 years ago and it was manual, right? So the outcome here is that you don't need to, or you shouldn't think about cloud being not compliant or hard to get compliance. Focus on your compliance process itself, right? So that's something we see quite often as well. Another random thing, on-prem authentication used for the cloud. So authentication is quite tricky. I'm not gonna lie. Authentication is quite tricky in hybrid cloud. In theory, it's very easy because, right? So let's say you have all your users in Active Directory and then you are moving to cloud. So most of the cloud providers give you an easy way to just sync all your accounts from your Active Directory on-prem to the cloud, and you're pretty much done, right? So in theory, it's very easy. And sometimes actually, if you're lucky, it can work like that. But in practice, what we see very often is that companies make very interesting decisions, weird decisions, to not go that way. And then we have a lot of different processes or a lot of different mind-blowing sessions how to do the authentication, because companies either don't want to sync their accounts to the cloud, maybe it's because they treat it not secure by default, or what also happens often, there is no one system on-prem for user authentications, but there are like 3 different, and they sort of cooperate with each other, or even depending on the department, or depending on the application developers are working on, maybe they actually need to use different applications systems on-prem. No matter what the reason is, the point is that quite often the easiest solution of just syncing account from the cloud to on-prem is not what companies are going for. Last will be networking. So one before last, very important. Again, this may be obvious, but cloud skills or lack of cloud skills, this is probably one of the biggest reasons why hybrid cloud can be not good, let's say. But what I mean by that, because I guess everyone is aware that when you're moving to cloud, you need some cloud skills, right? So again, that's obvious. But the point here is that engineers who are working on on-prem environment very often tend to think that, yeah, I need to learn something extra for the cloud. But in general, as the first wave or the first step, we will be using virtual machines and storage and networking and maybe Kubernetes, and that's all, right? And they already know how to use virtual machines because that resource exists pretty much the same on-prem. They already maybe know how to use Kubernetes because yeah, you can use Kubernetes on-prem. But the point is that all these initial resources, or all the resources that are usually chosen as the first, they are sort of standard and easy, right? So people don't really upscale for the cloud that hard at the very beginnings, because again, we are talking about simple resources. But once you start building that hybrid cloud environment, and you don't even realize once you are deep into the cloud, thinking about different sort of network mechanisms, different sort of ways of doing the same stuff, and you are solving the problems on a daily basis without actually realizing, oh, I'm already so deep in that I could actually use that skills. Another thing is that something that may be very simple on-prem, like let's say, yeah, virtual machines or networking, so how to create a VNet and stuff like that. Something that may seem easy, it's not really on. It's not really easy on cloud, and it's not because cloud is difficult or cloud is complex by default, but it's mainly because cloud gives you a lot of options, a lot of configurations. And at the very beginning, yeah, most people tend to scale to just defaults just to try it out. But once you start building all the infrastructure of the automation, you start using these defaults and it all works fine. Your pipeline can deploy your virtual machines, your Kubernetes clusters and stuff like that. And you are happy that it's actually, yeah, quite easy. It's not that complicated as people think. But then when you are happy with that, let's say, prototype pipeline, and you want to make it production grade, let's say, that's where it's becoming extremely complicated, like on a daily basis, right? Because deploying AKS, let's say deploying AKS on cloud with Terraform, that's what, like 10, 15 minutes of work, maybe 1 hour. You pretty much just go to Terraform documentation, copy paste the Kubernetes block, put it in your Terraform code, run the Terraform code, maybe change a few parameters which you forgot about, and you have Kubernetes, right? So it seems like pretty simple. But then again, when you want to make it production grade and you start reading all of the configurations options on this Terraform documentations for Kubernetes and on the cloud, then you have no idea what you are reading, no idea what these specific parameters are related to. And more importantly, you don't know which one you actually should use, which one are best practices. And some of the parameters have dependencies or other services. Quite a lot of parameters have dependencies on some specifics of the networks. So it's going extremely complicated, very, very easy, right? So not having that upskill on the very top of the list, not thinking about it, or thinking about it as that's something that can be done later when you go into more advanced stuff, can simply backfire. Okay, and last but not least, actually the most difficult one, networking. So networking arguably is the most difficult part in hybrid cloud environments for the very, very, very specific reason. Again, as I was talking about hybrid cloud in the beginning, or actually what drives companies to move to hybrid cloud, right? So one of the very reasons is that it's easy to migrate and make that migration to the cloud step by step. So at the beginning, you sort of just deploy some very not important test applications, and then you move slowly there, right? So because of that, because on the beginning of hybrid cloud journey, you usually think about that cloud part as experimental or just testing or stuff like that, then there is usually very little thinking put into how to structure networking for hybrid cloud scenarios. And what it usually means is that you end up in the situation that, okay, we have quite a few different complicated processes on-prem for the networking. Let's just use them for the cloud for now. And if we ever go to the cloud fully, then we'll revise that. And what it means is that usually you end up in the situation that whatever you want to deploy on cloud, you'll have to get some sort of approval from on-prem networking team. Very often, the on-prem networking team will assign you subnet or CRDR or network range, which you can use for your cloud resources. Very often, the firewall will be just blocked by default to the cloud, and you'll have to ask for the rules to be open for everything you want to do. And this creates a lot of problems in the cloud. This is partially because, as I also mentioned, moving to cloud very often also means moving to containers, so moving to Kubernetes. And having that restrictions on network level for Kubernetes is something that you will have to fight with every single day. Simple example, you deploy AKS, so you deploy Kubernetes on Azure, right? Normally, what Microsoft recommends is use Azure CNI for the networking level, right? Because it's newer, it's more modern, it's better than standard old school kubenet. Fine, so you go do that, but then you're asking this networking team, maybe even if you have some automated system, but you're asking the networking team to give you the subnet for that new shiny Kubernetes of yours. And they're coming back with /27. So you have just a few IP addresses for that Kubernetes. And then you realize, oh, wait, but Azure CNI assigns IP address from that subnet to each pod, which means if you are talking about any serious workload, so you have dozens of even hundreds of containers, you will need dozens of hundreds of IP addresses. But that's never going to happen because on-prem networking team will probably see things differently. They don't want to give you like the whole /16. They usually will try to give you very small subnets because that's how it works on-prem, right? You don't waste IP addresses on-prem. So then you're like, okay, then we need to find another solutions. And here you have already your first problem, right? Just because of that networking, not thinking about networking or treating networking in the cloud the same as on-prem. But okay, you may be like, okay, well, we'll just work around it, find another solution. So then you realize that, oh, you can use kubenet. Okay, you can use kubenet instead of Azure CNI, right? It's people say it's more old school, but it's just networking layer, right? So we don't care that much. So yeah, maybe for those who don't know, kubenet does nothing of IP addresses for the pods, which means, yeah, it only needs a couple of IP addresses for the nodes for the Kubernetes, and it don't waste, in quotes, IP addresses for the pods. So then you do that. But then you realize, oh, but actually kubenet requires elevated privileges. So your user who, like if you want to be secure again in cloud, right? So you give users as less privileges as possible. And I realized that user who was able to deploy Kubernetes through your fancy automated solution he was able to deploy Kubernetes with Azure CNI. He's not able to deploy Kubernetes with Kubernetes because Kubernetes requires elevated privileges. And then you have your second problem. And then you are in the situations that you're spending weeks trying to figure out what to actually do. And the only reason for that is because you are treating networking in the cloud the on-prem way. So that assigning CRDRs from on-prem is one thing. Another thing, I actually mentioned about that, but I'll talk about that again because that's also something we see extremely often, and it's extremely difficult firewall, right? firewall, when you go to cloud in hybrid cloud scenarios, very often will be just blocked by default, right? Because again, cloud is usually treated as not secure by default, so firewall is closed by default. Some companies may, for example, open 443 by default only, and I don't know, DNS, but by default, in most cases, what we see is that firewall will be closed, and you'll have to send a firewall request for everything. Basically, anytime you will want to have some connectivity from the cloud to on-prem. And you may be thinking, okay, yeah, okay, sounds complicated, pain in the ass maybe, but once you get all these initial firewalls requests, then you are good to go, right? Well, one may think, but in reality, it's not the case. Very often, you will end up spending weeks or months sending this file request, because the point of cloud is that stuff changes in cloud. And even if you assign some specific subnet to your application or to your Kubernetes cluster, so that IP address shouldn't change, right? Well, it may not change for that specific cluster or for that specific application, but as soon as you start thinking about, I don't know, multi-cluster stuff, or adding another clusters for another regions, or adding completely new applications, you will always end up having some sort of connection blocked, either from resources that change for whatever reasons, or from new resources that you deployed that you didn't think about before. Nevertheless, sending firewall requests for each and every connection from cloud to on-prem will be a huge blocker, and it almost always is. Now, again, I'm definitely not saying that you should open firewall to the cloud and let everything just flowing free, right? No, let's not go from one extreme to another. There are ways to solve that. I don't have a golden solution for you, because it very much depends on the company specifics, but there are ways of solving most of these problems. I'm not gonna lie, don't have a solutions for all of them, but most of them. So if I would have to pick two most annoying things which I see in the hybrid cloud, yeah, I would have hard times. Definitely firewall rules would be maybe one of them, maybe the one that gives me the most headaches. But there is something else that I didn't talk about on the previous slide. Duplicated solutions. What I mean by that is, usually it comes from that networking structure, right? So you just treat the cloud as extension of on-prem, and you use it on-prem stuff to manage cloud. But very often you will end up, basically duplicating solutions for very specific tasks on cloud because of a couple of reasons. First of all, some reasons like I already mentioned, let's say networking, or having that custom authentication solution on-prem. So if you have that custom authentication component on-prem and you can't easily migrate it, or you can't do anything about it, then what do? Well, you build another authentication solution on the cloud, which will sort of try to gap the authentication, cloud native authentication, with your on-prem authentication. Similar things usually happen with monitoring. For cloud, you will probably build separate monitoring than on-prem for a couple of reasons. First of all, on-premise, you usually have just servers and network stuff, right? And storage. So you have just 3 types of resources. So usually on-prem based monitoring solutions, the only thing they need is just IP address, and they can understand what's there, they can monitor stuff. In the cloud, you have dozens of different services. They all work completely different. So you can't just extend your monitoring from on-prem to the cloud, unless you're only using virtual machines on the cloud. But in general, services in the cloud differs quite a lot from what monitoring used to see on-prem. And also even some of the basic services like virtual machines, depending what kind of monitoring you're using, from on-prem, for example, virtual machine may be not one resource, right? It may consist of storage, which can be separate resource from the point of view of the cloud. Network interface can be actually separate resource from the point of the cloud, which is just linked to this VM. So even sometimes you'll have difficulties with basic services. But coming back to the point of duplicated solutions, this is a very tricky one, because very often you won't even realize that you are duplicating a lot after you already duplicated a lot. Because you start thinking, oh, okay, we need for this custom authentication, we need a component on cloud because we can do this. Then you start building monitoring in the cloud separately because it sort of makes sense. Then somewhere along the way, you need some other component because of XYZ. And after a couple of months of building all the stuff, when you look at it from the high level perspective, you actually realize, oh, okay, so instead of adding cloud to our on-prem, helping us and just getting more flexibility, more scalability, we actually just duplicated a lot of solutions, and it works fine, right? But was it actually worth it? It's not what we were hoping for. So yeah, I would have difficulty picking these two up. I'm hoping to hear some opinions from the audience after the talk. So I'll give you some tips how to overcome some of these issues, but please don't get me wrong. I'm not saying that using these three will automatically solve the problems. It's also not specifically about the tools, but also, tool specific matters here. But the first and most important solution to many of the hybrid cloud issues is not tools, right? It's not Crossplane, not Pulumi, not Cilium, it's mindset. You'll have to understand what actually you are getting into, what was the point of moving to the hybrid cloud, and having that understanding that cloud works differently than on-prem, and not treating cloud as on-prem extension, that will already solve upfront quite a few of the issues we were talking about. But if you want to go into some specifics, I listed here 3 tools that works quite well in hybrid cloud scenarios. But then again, these are just examples. It doesn't mean if you use them, you'll be fine. So very quickly, Crossplane. Crossplane is a tool for deploying infrastructure, but it works in a way that you deploy it on Kubernetes cluster, and then someone from operations team, or however you call the team which is not developing the applications, create sort of templates or guidelines, or sort of template to say how resources is supposed to look like when developer requests them, right? So coming back to the example I gave before, if you want to make sure that your developers or the applications team can't deploy virtual machines with public IP attached, then this sort of stuff you could do with Crossplane, right? So you define whenever developer requests the VM, make sure that public IP is not there. Or whenever developer requests resource X, make sure that resource Y is also created. Or whenever developer requests, I don't know, let's say VNet, then make sure that you create VNet, you create subnet, you create firewall rules. You can bundle whatever you want and make some guide rails in this sort of Crossplane templates. And then you give developers freedom to manage their infrastructure, which means they can request any resource they want, because they are doing this request through Crossplane, and you manage how actually this resource will be looking like. So you have idea how, or you know that they won't build something that you don't want to. you will have easy also way to see what's deployed. And also crossplane is also sometimes nice solution to the problem of introducing Terraform to developer teams, right? If you have very typical old school on-prem environment, so like your developers never seen Terraform in their life, and now you want to move to cloud, so usually, yeah, you will build Terraform to manage infrastructure, so your developers will have to learn Terraform, how to use it. And that's not something actually nice, right? Why developers should learn your infra tool. With crossplane, you request the infrastructure, make this infrastructure request via YAML, right? Because again, it's installed in Kubernetes, so they'll have to learn Kubernetes anyway if you are moving to containers, so they will already sort of understand how it works. And well, the YAML is simple itself. So instead of teaching them how to write Terraform code, then you having on you this burden of how to make sure that actually they don't put something in Terraform that you don't want. Maybe you could solve that with Terraform modules, but then again, you need to develop that module. With crossplane, you can do this much easier, right? You just define YAML file when you're saying if VM, no public IP, something like that, simple stuff. You can do it also both ways with crossplane. So you can either only allow what you want to be allowed. So let's say you only allowing VMs and Kubernetes to be created and nothing else. Or you do it all the way around and you only specify what's disallowed. All right. So developer can create anything except this and that. Or again, developer can create however VM they want, but without this and that. So that's one tip. Another tip, Pulumi. So Pulumi is basically direct competitor to Terraform. So it's an infrastructure as code tool. The difference is that with Pulumi, you write infrastructure as code in normal programming language. So you can use JavaScript, you can use Python, you can use, I think, Go, and I think some others. But the point is defining infrastructure or writing infrastructure automation with Pulumi is not done with specific language like with Terraform, but with the language that developers already know. Which then again brings us to the point that you don't need to force your developers to learn Terraform, which is not only good because just because of that, right? Because developers don't need to learn something new, but because they already if they are already developing in a language, they probably already know best practices for that language, which brings you like 3 steps that you're skipping 3 steps that developer normally would go through if they have to learn Terraform, right? First, learn what is Terraform in general. Next, make like first steps in Terraform, create some simple resources, and then third step, learn how to actually write good Terraform code, right? So that's one advantage of Pulumi. Another advantage of Pulumi, which makes it specifically nice for usage in hybrid cloud environments, is that since you are defining the infrastructure with programming language of your choice, you have all the advantages / libraries of that programming language, which means if you need to do something very specific, like, for example, whenever you're building your infrastructure in the cloud, you need to make an API call to on-prem system to get some approval or I don't know, get some networking sorted out. Then with Terraform, you would have to do some sketchy things like using null providers or executing some bash scripts under the hood to make that HTTP call. With Pulumi, you just do it natively because, again, you just use HTTP library of your choice, and it's just native. It's nothing wrong with that. So that's really nice for specifically for hybrid cloud environments. And last tool I want to quickly mention is Cilium. So Cilium is cloud native networking and security provider. primarily used for Kubernetes, but very importantly, it's not Kubernetes only, right? So what Cilium is for Kubernetes is a CNI basically, right? So it can manage IP addressing for your pods. It can manage security for your Kubernetes. But the difference is that Cilium operates on layer 7. And what it means that traditional, we were talking about firewall rules on the slide before, and traditional firewalls just operate on layer 3, right? So we specify this IP address can talk to this IP address on this port and this protocol. And as most of you are already aware, I guess, that doesn't really work well in cloud environment or in Kubernetes, because IP addresses of pods change anytime, right? Kubernetes IP addresses can change anytime. I'm talking about ingress or even pods if they're Auto-Scaler and stuff like that. So in general, this IP port protocol approach is simply not well suited for the cloud, specifically for containers. So what Cilium provides you is doing this in cloud native way on layer 7, which means you can specify that pod A can talk to pod B, and it can only do HTTP GET and POST, or pods in this group can only subscribe to Kafka topic, this specific Kafka topic, and another pod can only write to another Kafka topic, right? So it's layer 7, it understands Kubernetes, so security is simply native on Kubernetes. It's just so much more intelligent or good for Kubernetes that it simply should be just default way of doing firewalling, let's say, in Kubernetes world. But as I mentioned before going to Kubernetes, Cilium is not only for Kubernetes. You can also install Cilium on virtual machines, on normal machines, and this is one of the reasons that it works pretty well in hybrid cloud environments, because you can then avoid all of this drama of having firewalls blocked by default and having a few days of waiting, of accepting firewall rules, or not trusting cloud by default. With Cilium, you can secure it much better than what you do by blocking everything with traditional firewall. And this is because very often when you have that situation that firewall is blocked by default between cloud and on-prem, and you need to open firewall request for each workflow, very often what companies are doing is they're requesting firewall rules to be open to the whole subnet instead of specific IP addresses, right? Because if you, for example, have your, I don't know, GitLab instance on premise, then you pretty much want all your machines to connect to GitLab from the cloud, right? Or if you have database on-prem and a couple of applications need to talk to that database, then again, you will open a port of the database to the whole subnet. And then if you think about it, you will end up in the situation that you have that firewall, which blocks everything from the cloud to on-prem, but then you are opening these firewalls to the whole subnet, even to the machines or pods or workloads, which actually shouldn't have that access, right? Just because it's easier, just because it's less painful. So then, instead of having that old school or not really as secure as it seems like solution, you could have much higher security with cloud native solution, basically, like Cilium. So again, these were just 3 examples, and I mentioned that again, it doesn't mean you'll succeed with hybrid cloud if you use all of them. It also depends quite a lot on the company specific, of course, but these are just tips or stuff that you could look into. And that brings me to the end, finally, of my take. I think I overshoot a bit with the time. Sorry about that. But if we have still a little bit of time, I'm happy to answer some questions if there are some questions. Thank you very much.
Well, thank you so much, David. That was really good. We have, let me check the questions. We had one up there. Okay, this one's from Bala. I hope I'm not butchering your name, and it might not be the first thing I butchered today, but would you prefer stepping up and asking your question? But I guess we don't have Bala right now. Okay, I'll ask the question. Do you use any tools to benchmark compliance and data transfer in hybrid cloud?
Yes, definitely. I actually should have mentioned about that when I was talking about compliance difficulties with the cloud. But yeah, one of the easy solutions is just to use the tool, which can automatically scan all your environment for compliance. Of course, very often it's not as simple as just installing tool, having one scan, and you are good to go. But that tool will give you sort of kickstart, right? You have already, let's say, 70% of the job done to make your cloud environment compliant. So then the rest is much easier. Yeah, so definitely.
Yeah, okay. I guess we don't have any other questions from the audience, but I will definitely ask them to, shoot more questions and step up. I have one myself. It's a little bit too conceptual though.
Mm-hmm.
When you were talking about security, you made me think that there's a huge gap between companies' understanding of security in cloud and the actual security in cloud. How do we close this gap? What should companies do? Or I don't know, what should cloud providers do? Or do they even have to do anything? That was my question.
Fair question. So this is specifically a problem what you mentioned in Kubernetes. Because what we see very often is that if a company has a policy to have all the traffic encrypted, right, which is not that uncommon, if that policy exists on-prem, then of course they want to apply the same in cloud. And then you are ending up in a situations that, okay, so we actually need to encrypt all the traffic within our Kubernetes cluster, which is not that trivial, right? You can use stuff like Istio, which is not trivial. But the point is that this is actually not giving you the security that they think, right? Because again, if you are on-prem, you have two virtual machines, then yeah, it's quite understandable that you want to encrypt the traffic between them. But if you have two pods in Kubernetes cluster, then having that traffic encrypted, it only gives you some sort of security, if you have another malicious pod in that Kubernetes cluster. And having malicious code injected into Kubernetes cluster is much bigger problem in general from the security perspective, which means if someone is able to inject a pod into your Kubernetes cluster, then that encryption between your pods doesn't really matter, because it means that he can probably get some admin rights to deploy anything, so he can do much more complicated stuff than just sniffing your traffic. Yeah, so the solutions to that, it's not trivial. What we usually suggest, what we usually try to do is to, instead of waiting or like fighting with CISO teams, with security teams on-prem, sometimes what works, but it doesn't work always. Sometimes what it works, that is we create, we as a consultant with the team which manages the cloud on the client side, we try to sort of create security on our own, right? So we use some good practices, we use some automatic security scanners for Kubernetes. We try to do as much as we can ourselves. And then we go to CISO and we are saying, hey, look, we did all of this effort to secure our Kubernetes cluster. Is it fine for you? And in such cases, very often the CISO team is just approves, right? Because they are also not, that they want to make sure that the stuff is secure, right? Their job is not to make our life hard. They just want to make it secure. So if you're coming to them and just asking what we need to do, then by default, they will just tell you what the policies are currently. But if you're coming to them with already something, and if that something is quite nice, then quite often that works.
Okay.
And if it doesn't, then yeah, you'll have to do some stuff that you wouldn't need to normally, like install Istio to encrypt traffic, or actually Cilium can also encrypt traffic. So there are also ways to solve that.
Yeah. I also meant to ask about the idea of lift and shift. Is this a pitfall that companies kind of fall, because it makes it look like very easy, right?
Yes. So I hope my colleagues from Kubernetes Solutions won't kill me, but I think actually lift and shift sometimes is not as bad idea as it may seem. In general, it's bad idea, yes, but it's mainly it's worst idea if you are moving to cloud only. If you are starting in the cloud from scratch, if you're doing lift and shift, then I would definitely not suggest that. But if you are in hybrid cloud environment, then yes, it's quite a simple way, of course, to move to the cloud. That's why also a lot of people do it. It has definitely disadvantages, but it's not as bad in hybrid cloud because it overloads you from a lot of thinking, right? So you don't need to redesign the application. You don't need to rethink everything, which means you have a bit more time, actually, and a bit more brain power to think about all of the stuff we are talking about. So, or actually think about networking well, think about security well. So from that perspective, I would say, yeah, you can do it sometimes, let's say.
Okay. That was a spooky Software Circus, so you could say that, I guess. Yeah. Well, thank you again, Dawid, for doing this amazing talk and presentation to us. It's been amazing. And I'd like to remind you about our upcoming events, which is our, cyberpunk thing, which it will be happening on next Thursday. And so don't forget to sign up. And if you're in Amsterdam or Berlin area, we are hosting 2 watch parties. So there'll be some swag involved as well, and fun, as you can imagine. And yeah, now we've resurrected Software Circus on this bloody night, I guess. We really want and need your support. Please come join us. We'll be doing this monthly. And yeah, you can also try if you have a talk. It's just about having fun and, trying and failing. So thanks for joining us tonight. And if you have anything to say, please step up and, just enjoy the fun.
Thank you.